Bun, the JavaScript runtime that's trying to replace Node, is written in a language called Zig. So is TigerBeetle, a database built for moving money, and so is Ghostty, the terminal from the creator of Terraform. Three very different projects that all landed on the same fairly obscure language, one that sits in the top 5 most admired in Stack Overflow's latest survey, even though most developers have never seen a line of it. So I figured we just look at it. We'll use the real compiler on real programs, and along the way, you'll see it catch a memory leak, refuse to compile a bug, and build for 3 operating systems from one Windows machine. Here's about the smallest Zig program you can write. The first line pulls in the standard library, and it just gets assigned to a constant like any other value. And then print, which already tells you a lot about this language because it won't just take a string. It wants a text and then a separate list of what goes into it. That little dot brace at the end, even when the list is empty. It feels pedantic for about 5 minutes until you realize the whole language works like this. And nothing ever happens that you can't see in the file. And when it runs, there's our hello from Zig. Now, error handling, which is honestly the thing that made a lot of people fall for this language. In C, a function that fails usually hands you back a negative one, and it's on you to remember to check for it. Zig moves the failure into the type. This parse function returns that exclamation mark U8, which they call an error union, and it just means you get a number back or you get an error. If you call the function and ignore that possibility, the compiler won't build your program. And it's worth reading what it actually says when it refuses. Because along with the error it suggests, consider using try, catch, or if. It found the bug and then offered 3 ways to fix it. So we take its advice, put a try in front, and feed it something that isn't a number. And now the error travels up and the report points at the exact 2 lines in this file that pass it along. All right, memory, which is the part everyone assumes has to be painful. Anything in Zig that needs memory has to be handed an allocator as an argument, so you can always see right in the code where memory is being asked for. This program asks for 1,000 integers and never frees them, which is exactly the kind of bug that sails through a code review. And when it runs, it works. It prints, it exits, nobody complains. But the allocator we're using here is a debug allocator, so when the program ends, it goes, hang on, this address never got freed, and here's the line that allocated it. That's a bug that would normally surface weeks later in production, and instead, you're reading its line number. The fix is defer, which means run this when the function ends, however it ends. So the free sits directly under the alloc, and you can't really forget it anymore. Here's a smaller save that I think says a lot. This health value is a U8, 1 byte, so the biggest number it can hold is 255. Add 10 past that in C and the number quietly wraps around to 4. There's no error anywhere. The value is just wrong now, and the rest of the program keeps computing with it. Zig stops the program instead with a panic that says integer overflow and a caret pointing at the exact plus sign that did it. It would rather crash loudly than keep running with the wrong number, and honestly, so would I. Okay, the party trick. This block at the top builds a little table of squares, and if you look at the output, it says built during compilation because that's genuinely where the loop ran. The compiler executed it while building, and the finished program just carries the 10 answers around as data. Zig people call this Comptime, and it's their whole answer to C's preprocessor. There's no separate macro language to learn. It's ordinary Zig code that's allowed to run early, and it's been working this whole video without you noticing because print is built on it. The format string gets checked during compilation, so if I ask it to print a string as if it were a number, the build fails before there's even a program to run. And then there's the toolchain, which is where Zig starts showing off. This is the same hello world from earlier, built 3 times for Linux on ARM, for macOS, and for WebAssembly, and all 3 just worked. On this Windows machine with no extra toolchains installed, the file tool confirms they're real, an actual Linux executable, an actual macOS binary, actual WebAssembly. And hiding in here is ZigCC, because Zig ships an entire C compiler inside itself. It's Clang under the hood, and it gets the same cross-compiling abilities, so it builds a plain C file, runs it, and if you ask for that C file on ARM Linux instead, it just does it. Zig didn't set out to fight C so much as absorb it. Now, before this turns into an ad, the honest part. Zig is at version 0.16 and it isn't finished. This array list code is what every tutorial was teaching a year ago, and today's compiler rejects it because the standard library got redesigned in between. That's normal here. The language still changes shape between releases, and building something real on Zig means migrating it on a schedule you don't control. The safety has limits too. That leak earlier was caught while the program was running because a debug allocator happened to be watching. Rust, for comparison, makes a lot of those mistakes impossible before the program even exists. Zig's deal is that you can see everything, not that you're protected from everything. So if what you want is a finished, stable language, this isn't that yet. So why do developers love this thing? I think it mostly comes down to the fact that you can hold the entire language in your head. It's doing C's job 40 years later with everything out in the open, the errors, the memory, the compile time code, all of it sitting right there in the file. And the teams behind Bun and TigerBeetle and Ghostty had every language in the world to choose from, and this is the one they chose. What C should have been is a big claim to put on a language that isn't finished. But after watching it work, it's hard to come up with a shorter, honest description.